So originally, when I proposed this talk, I sort of went above and beyond and thought, okay, I'll do RegEx and I'll do XPath, and I figured, let's just throw in some stuff about the James path as well. And then sort of the slides started piling up, and I figured, let's just do RegEx. Because, and yeah, this is sort of nerd factor 11 compared to enterprise information models and stuff like that. So for those of you who think that this looks a bit scary, just check your phones or whatever. I by no means claim to be an expert here, and I'm pretty sure at least, that there are people here who are far better than me. But the stuff that I always, or not always, but often see, especially on Teams, is, ooh, this is RegEx, it's scary, I hate it, no, shy away from me, and then people garlic, crosses, silver bullets, that sort of stuff. So consider this like a basic 101 introduction to regular expressions, as they're more normally called. And as I'll get back to, it's for searching for patterns in text. That sounds pretty damn boring, but it's often the stuff that we do. So in DevOps, you got a 15 gigabyte log file filled with stuff. And what I see often are people downloading it and then just going, but Notepad++ blows up when I try and open the file, so I'll try Ultra Edit. Oh, yeah, that blew up too. And I'm going, for God's sake, there is less, and there is grep, so just look for it. And then they go, but there's a regular expression. It sounds scary. So this is sort of one attempt at demystifying regular expressions. Really quick about me. 22 odd years plus in the business, various companies, before I finally saw that the grass was greener on the other side and joined .NET in 2015. They promptly lost my application, but I argued my way in. I've been doing things with implementation, design, architecture, performance, Solaris, Linux, ZFS. I've programmed Java since 096. That's kind of cool. Tickle, Kubul, I did once. Never write it on your LinkedIn profile. You'll get swamped with calls from the City of London. In Elhub, I'm kind of like a potato, but together with Christopher, we run the platform team. Regular expressions. They can tend to backfire. So trolling Russians is obviously really popular these days, but they occasionally troll themselves. They try to throttle Twitter and basically promptly shut out any traffic from Microsoft.com or Reddit, whatever, all because of a malformed regular expression. For those of you who really want to learn about this, this is sort of the Rosetta Stone for regular expression. Buy that book. It gives lots and lots of really good examples, but it also details sort of the underpinnings, the engines behind regular expressions. And when you start looking at how it parses this hieroglyphic-looking piece of squibbly things, and then manages to sort through gigabytes and gigabytes of text, and pops out with that one line that you're looking for, the respect for those that wrote those regular expression engines, they grow. If you don't want to buy this book, then use the website regex101.com, which is sort of, again, why doesn't this work? Okay, whatever. Now then, use that website, regex101.com. Paste in some stuff, and then there's a handy selection of various dialects, which I'll get back to a little bit later. And there is explanation for the various bits of squiggly text and lines and signs and whatnot. So use that one, and then it explains in great detail what is actually going on in your text searching and your pattern matching. Nevertheless, where is that little thingy down there? And Bob's your uncle. Right, so where can I use regular expressions? basically everywhere, at least in the Linux world. In Windows, you have that stupid globbing stuff where WildStar and the question mark, that's available for searching, but then Windows has always been way behind. This is an example from VS Code. So one of the linting rules that Christopher and I have in our code is there shall be no white space at the end of lines, because that basically just looks nasty and is untidy and unprofessional. So if you really want to search through your code base, there's a regular expression searcher there, that little square with a star, and then you can have a expression that looks for any character and the line ending anchor, which I'll get back to. So it is supported in most grown-up tools, and especially when you start working with Unix or Linux command line tools, like less or grep or sed or awk or whatever, there is support for it. However, with some gotchas. So this is a list from Wikipedia of the most common regular expression implementations. So often, if this thing works or doesn't work, it could be useful to see if I'm doing something fairly advanced or whatever, like stuff like look ahead in text to find patterns. You can use this list to see is that actually supported, because whilst it might work in the RegEx 101, it might not work from your Java code or Tickle code or wherever, based on the implementation and the behavior of the backend regular expression engine. The core of it is regular expressions are for pattern matching. So if you want to find something that consists of a format that you can define, like glns or elan numbers or whatever, or error messages with uppercases or lowercases or whatever, in large files or even small files, then regular expressions are for you, and they're not scary. So I'm going to give first some warnings, but I'll introduce you to the basics. Christopher reminded me of this warning. Once you learn regular expressions, they tend to, you tend to gravitate towards doing everything with regular expressions. Don't do that, because things just become too boggled down and complicated. Often it can be useful to reconsider the angle that you're attacking things on. If you've got a large wad of text and then you think, is everything in uppercase? Well, that's kind of a hard problem versus is anything else not in uppercase? So try and turn the problems around if they don't really fit what RegEx is about. And then there's character sets. They can be really, really hard, especially if you're working multi-domain. Say that you have language files in Turkish. This thing here is a Turkish I, which is a character, valid one in their alphabet. However, when you get it in 9-point ASCII or 9-point console output, that regular I that we are used to just looks plain identical to that one. It actually cost us 2 weeks of work with with Turkcell, because it simply didn't work, and we figured out that some bugger had stuck a Turkish I in a domain name, which wasn't supported at the time. So yeah. Anyway, characters. There are two types of characters in regular expressions. The usual one that we all know and love are literal characters. So ABC, whatever character that you can express. And you have special characters, meta characters. They mean something. And if you use them, they can be a shorthand, which I'll get back to. Or if you actually do mean /W, you have to escape it. So another slash escapes it, and you're good to go. Usual type of escapes that you will find whenever you're programming. So matching strings, the yellow is the match. And on the left hand there's like the regular expression. It can look, if you're just looking for literal characters, it looks perfectly like searching for a string in any other notepad find or whatever. But once you start looking for more advanced, because in regular expression you define a pattern that you're searching for in your text, and that pattern can take many forms. I'm also now, for the sake of this presentation, ignoring expression modifiers, where you can say that this expression doesn't return after the first match, or this expression ignores line breaks, that sort of stuff. So using expressions, you can modify the scope of where your regular expression applies. So, but stay away from them initially. They can just confuse things, something wicked. First thing, and probably the stuff that most people have done is, I've got dot star, and cool, that's a regular expression. Yes, it is. It's a very simple one. But dot is a meta character. It can mean any character. So if you can see the hello world on the top right there. I don't know why it says 2020. I must have been drunk. But it means any character. So a dot would just match all of those. Now, the wild star, that's for repetition. And the intent behind the different coloring here is to say, where did I get the match? So in the first one, the dot would just match any of those characters. Whilst here I say any character as many times as you can. So one of the important concepts in regular expressions is about greed. So in the words of whomever, greed is good, well, occasionally, because it sort of allows you to have shorter, more concise expressions of what you want to match. I could have said dot to match the entire thing up on top. That's kind of dumb, so I just say, give me any character as many times as you can. And yeah, escaping. Use the backward slash to escape them, because then you want to say that I want to match a literal character, not a meta character. There is a notion of things like called character classes. So a character class can be a subset of either a range of characters, in this case, A to Z. So that would imply every character from A to Z in the ASCII table. Or you can use individual characters to say, match any of these, but not all the rest. Uppercases, digits, etc. You can have more complex character classes, and this one would match any character, lowercase, uppercase, and digits, including underscore and exclamation mark. And of course, that would match a single character. If you want a string of characters to be matched, as far as that greed would allow, then you use the star, or can use the star, as a repeating element. There are other alternatives, we'll get back to those. You also have negation, saying match everything, not these. So that allows you to define character classes. Then there's a shorthand. So in this case, the /d, it means basically the same as this. But they're not supported everywhere. So if you're fond of using grep or egrep in the CLI, you will find that /d, it just goes, don't know what that means, which of course has an alternative on the lower right there. But you have to test these things. You can't just blindly trust it, but after a while you get used to it. More shorthand characters. This one is really useful. The lower s, white space, and then obviously the opposite, stuff not white space. So the entire dot star thing could, in this case, have been replaced with /s and then a repetition element that will match any character and not the white space. Yes. Quantification. So it's about repetition. So I introduced you to the star, which basically says 0 or more, and I got 5 minutes left, but I'll ignore that. So there are other mechanisms here. At least one of those, the plus, star, 0 or more, question mark, optional. Or you can say, typically for a character class, I want this matched twice, or 2 to 4 times, or at least, or maximum 4 times. I can do hell, and I say, because this is really nerdy, and I'm saying at least 1, so this actually matches both of those variants of hello. And I can do treat the literal character and just make counting of those. Anchors, I'm sure you've seen, that doesn't have, may not always have understood, but there are particular anchors, especially if you're talking about standalone regular expressions. Meta characters again, start of line, end of line, which are really, really useful for determining if a pattern, where it's located in relation to a line of text, rather than if there's something that should be dictated, that this has to start with it, then yeah, include the anchors. If not, then you would match at random at any other place within the line. Or the pipe character, so very useful as well, used to match either or. You can see examples. Slides will be published later. Now these are nice, group constructs. And they're especially nice if you want to talk, if you want to refer to a match later. Say that you have a line. I want to have everything at the front of the line as a group. And then I want to substitute the middle of the line, and I want to treat the remainder of the line. Then I can refer to groups later. I can also refer to named groups whenever I do pattern matching, so that you won't have to have like these obsessively long expressions. So they are, when you progress past dot star, this is the next thing that you will find useful, group constructs. And I have a couple of demonstrations for those. So this is part of the Ansible code that we have in Elhub. So we're looking for the boot configuration, and we want to ensure that SE Linux isn't there. So using the backrefs functionality of Ansible, I can then refer to, and this is just by index, so you got a group containing the beginning of the line, because there's a line anchor within the group. So starting with this, and then optionally, because that's something called a non-capturing group, which means it doesn't get its own index. And I can say, yep, just put in group 1 and group 3, which is the little chap over here, the remainder of the line. So effectively discarding this SE Linux disablement. Again, another example. We're doing fluent parsing of log files in Oracle Observability and Logging, which is a series of named groups, severity, host names, etc., with some white space, and then all the text that's in it. This actually translates, in our case, into a JSON record in the logging infrastructure. All right, more example. With capturing groups, because this is the way that you can, when you do, particularly if you do Ansible or any other sort of substitution, this is where you can refer to matches and then discard them or include them. I think my time is out, so I'll sort of end with this empowering slide of what people see as power.